in confidential. Oh,
No, this is my other Windows.
yeah, okay.
It's sad to say this, but well, it is what it is. All right, so is it
Anta, can you
recording?
talk?
Matthew?
Yeah, I can.
Can we go?
Yeah, your audio is still busted though. So
Like how?
It's fine to me.
um, it's hard to tell. No. For us, it's fine.
Oh, on the on Twitch, you mean, right?
I mean, on the stream.
I think it was tweaked for the microphone, right? For the other microphone.
I think it's good enough, but you definitely should search for a new headset, man. Anyway.
Okay.
Anyway, so today, parsing stuff. I kind of want to do the easiest one first, which is the let.
Dude, let's kill them. Let's claim victory
The
smallly. It's on
kind is
small
the
ones
easiest
first.
one.
Yeah,
Which
it's
one is
just
the smallest? The easiest?
yeah. I think kinds are easy. Let's. I think they're also not hard.
Yeah, let should be fine.
Ooh. Maybe they are. How are we gonna distinguish? Okay, just by the label. Yeah, never mind. It's up to the user. The lets are easy. The other ones, I think they're a little harder.
I think that they are hard because you don't have a grammar. Because
Yes,
since some
let's
point
make our
we stopped
silverware.
using this document here, and I think we should go back to it.
So let's go back here to our
So,
silverware file.
what is a type? What is a kind? So,
Let's
a
do
kind is
this.
composed out of two things, which is a star and an arrow star. So maybe you're gonna. Okay, so let's make a star here, and you also can be an arrow star. What is a star?
It's literally a
Star
star.
is just this symbol.
Yeah.
And an arrow star is
Oh, this one is kinda.
let me think a little bit. Here we
Yeah,
are. We
that's
are.
not that
You
easy.
can do the same thing you did with the other. It's just really weird,
Yeah,
right?
it's this,
Yeah.
but instead of args, we're gonna have star, white spaces, star. No, not star. Sorry, kind.
Yeah.
Kind. White spaces kind, and then type right delimiter. We're gonna use the same delimiters for both kinds and types, right? So the parentheses.
Yes, I guess so.
Okay, so this is okay. So kinds are
If
done.
it is, I don't think it should matter, but if it is too hard, like if we find some problem, we can just use the curly braces.
Wait, I think something is wrong.
Go on, Nathan.
You cannot use a list in the way you did, right?
You cannot use a list.
Which list?
We don't have a list here.
I mean, can I say?
The delimiters, you mean?
No. If you take a look on your arrow for types, I guess you can do a list, right? So the inputs and the outputs, so you don't do a bunch of nested stuff.
Let me follow the same
Oh, the
convention that we did with
args.
types.
Yes, on the args you can. Actually, no. It's let me see. We have the args, which is just a delimiter of no empty args. No empty args,
No, empty args is this down here.
which is a list. That's true.
Yeah, this is a list with more than one element. Okay.
So yeah, with the kind there, we cannot do that. Like here.
Yeah, I agree that we can't do that. But I'm having a trouble understanding Matan's point, because as far as I can tell, we're gonna parse this today. This.
Go to our
Isn't
example 5.
okay, it's this. Mageta,
Function.
you are the one with the screen share, so if you could.
Yeah, I am a function. Where are you? Okay, you're here.
Yeah.
So what is the type signature of the the things.
Yeah, so we need to define that, right? So what is gonna be? I'm thinking about doing this the Haskell way of doing like that.
No, a type signature, not a kind thing.
Oh, okay. So a type signature of
Oh, we have one down there.
a normal type is this.
The expression that you have down there, down there, like line 8, right?
Yeah.
You have the arrow, right?
Mhm.
But there
Yeah.
you have like t to integer.
Yeah,
Like
it is a list of stuff in this
yes,
case.
exactly. I think we should have the same with kind, because otherwise it will be too nested.
Yeah. If it just translating this, by the way, it would be like this in that case, right?
Mm-hmm.
And if you have more stuff, like I don't know, an U. Oh, okay, it's not bound, but whatever. Another T, then it is another arrow T.
Yeah.
Oops. Yeah, you got the idea.
Yeah, that makes sense. So okay, so we need to we're gonna have to follow the same kind of philosophy that I did on the arg stuff.
Yeah, you can just copy, I guess, and
Yeah, but I'm not liking. I think we should separate the type level from the kind level because it's gonna get pretty messy pretty
What does
quickly.
that mean?
Having another org section or something just
Oh,
for kinds because I don't want to like mix type stuff with kind stuff. Okay, so we're gonna have like that. Um, and then in here we're gonna have types.
okay, but is it what we want? With just a one kind here?
No, it's not. We want args here. We want to make the same
Yeah.
equivalent that this, but for our new args, let's say. So something I'm gonna do,
Yeah,
I'm
just
gonna
copy
just
those
copy.
two.
We're gonna
And the
copy
line
this,
below.
but we also gonna let's start with this one. Later, kind args. What are so here? It's instead of kind, it's gonna be kind args. And when we did with the types, the kind args, where is that? Here. It returns a type, which means that this will return a kind. Okay, so now we
Yeah.
need to define what is kind args. So when we did for the types,
dude, we have a big problem of like not abstracting stuff there. Like what we
well,
need the list, right? It's a non-empty list.
yeah, we will get there. You are rushing.
Yeah,
But I
that's
mean, we have that everywhere, dude.
what do you
No, we don't.
mean?
We have only here.
Oh man,
As far as I can. No, we have other places, but in
that's
terms
not
of
a list
types,
in the sense that I'm talking about. I mean the list regarding our concrete syntax stuff. Like it begins with a parenthesis, it closes with a parenthesis, and inside it has a list of stuff that has at least one, right? We don't have
yeah.
abstraction for that in the grammar nor in the code, right?
Uh,
For
in the
lists, yes,
parsing,
and that's a big mistake because we're doing an S expressions without a list.
Without abstraction for parsing list, right?
Yes, that's
no,
very
yeah,
wrong.
but we already have the many people for the
No,
parsing.
no, no, no.
No,
You're
that
not.
doesn't.
No, you're not getting the point, Numis. Like the point is, we don't have the idea of the type list
Yeah,
in
we
our
don't.
language.
Yeah, we
Yes.
don't.
So that's
No,
the thing. It should be kind of a list.
wait, not sure if you are talking about the
No, no.
same thing.
This shouldn't. Yeah, I don't think so. Like,
What I
never mind
mean
what I was saying. It
is the
shouldn't be a list,
parser
right?
for a list where you receive a parser that says, "Oh, that's a
Hmm.
list of what," right? And then it depends exactly on what kind of list you want. Like for sure, it will have like parentheses around, it will have like spaces as delimiters and such. But then you need to choose the thing regarding, oh, is that a list that can be empty or that's a non-empty list, right? And that would be a parser that would be parameterized. Like we we could like simplify a lot of code.
I'm not getting the point because, as far as I can tell, what you are saying is adding the type list to Silverware, and we are not talking about that at the moment. So I'm
No,
not
no,
getting
no,
the
no,
point.
no.
Yeah, those
The
were two different
parser
things.
for
I
a
made the
list,
mistake.
the parser for a list is not returning a AST node for a list
Hmm.
expression. That's not it. Like it is returning for you a list of the stuff the parser brought you. Like that doesn't give you the AST. You need that you still use that to mount a AST node of something.
Yeah, that's what we were doing before. I'm not getting the problem. What is the problem?
Okay,
We were already doing that, right?
not in abstraction, man. We are repeating things everywhere.
Not in abstraction. We're repeating things everywhere. Yeah, I'm definitely not understanding Nathan.
Yeah,
Can you try, Maggot?
this part I also
Bro,
didn't understand.
like you are parsing that kind of stuff in a lot of places, right?
You mean
This kind of
this?
A
stuff,
list.
what?
A list? Yeah, we
Yeah.
have multiple
No, 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 no,
lists
no.
of.
A list in the sense of the concrete syntax, a nest expression. Like that start with parentheses and
So first of all, let's go here. Let's go here. So
We don't have a. I'm not
yeah,
understanding. We don't have a
no,
list.
wait. Let's go back. Let's go back. So there are concepts of list in S expressions, right? So
Yeah.
this 1, 2, 3, 4, 5. This is a list.
Yeah, we don't have that.
We don't have this,
Yeah,
no,
but
we just don't.
this.
it's simpler, man.
Wait,
Go to
wait.
the type, and you see that the type is a list, right? List of types.
Go to the type, and you see that the type is a
Like
list of
the
types. You
arrow, for
mean
example.
here?
No. The arrow there, line 10.
Line 10.
You see where you have the TT?
The TT, yeah.
That's a
Yes.
list of types, right?
Well,
Yes.
yes.
Now we will have a list of kinds, right?
Yes.
If you go to something else, like I guess the parameters itself, they also are a list that also have parentheses on the outside.
Yeah, you're correct. You're
That
talking about
kind
line
of
Yes.
38.
code we are repeating everywhere, right?
Yeah, we're
Yeah,
using
but
them. Yeah,
what
I'm
is
okay. Go to the functions.sw and go to line 38. Nah, Magita.
38?
Yeah, you see that we have this, and then this is
Yes.
actually like acting like a list. This.
Yeah.
Yeah, I agree with Nathan that we have multiple lists from the user point of view, and in order to handle those, we are just using the many parser. So what is the problem?
Yeah, that I also didn't understand.
Dude,
Yeah.
let's just forget about it.
No, man. I want to understand the problem. You said, "Oh, we have a bunch of list stuff," and we said yes.
Okay,
Yeah, the
And
problem
so
is I
being
just want to
concrete on the
reduce.
code, what changes?
Mm.
Let's suppose I want to parse a list of types, right? Then I type uh, list parsers, and then I pass an argument that is the parser for a type. Instead of that, we are writing a whole lot of stuff.
No, we're just using the mini, which does the same thing.
No, because inside this list parser, you would already have like all the white space part handle, all the parentheses handle.
oh,
Oh, you
he's
want
talking
the
about
okay, I
abstracting
see.
out
Yeah, exactly. I
So
get it.
the
with list,
the
I
Like
grammar
the
part of a list.
yeah.
and yeah, the thing I was saying, uh, applies to both, like the implementation and our grammar. Like our grammar is hard to read as fuck, man. And that's because everything is in line instead of being like abstracted in the same sense.
Yeah, so I can explain to you, Mageta, if you didn't
No,
get
I
it.
get it. I get it.
So he's suggesting to actually kind of like he wants to add a new thing to our meta language to allow us to have like a list parser that you
Yeah.
just say, oh, it is for types, it is for kinds, and it just fulfill the blank space, the blank spaces, but the delimiters are already there, the white spaces are already there, the arrows are already there, and you just put the play, you just replace the placeholders.
Mhm.
Yeah, we can do that. We can do that. So let's put.
I am just kind of thinking. Like I agree with the problem, but how hard would it be to change the rest? I'm not sure we should do this now, man.
No, we're gonna do that only in.
Like the new ones, that's fine, but change the rest is too much.
No, yeah, changing the rest is gonna be really challenging. How are we gonna make this thing like reusable for our grammar? Because you notice here that what changes between, look at the type arrow on the grammar. We're going to have exactly that, but for kinds. It's going to have the same type delimiter, the same white space star, the same arrow symbol, more white space star, and then what we have changed is different between the kind and the type version is that the type version has type args and the kind version has kind args.
Yeah, that's a tricky one because of the error, right? Not
Because
a
of the
not
arrow.
a homogeneous list per se.
Yeah. You
It's
have
not a
something like, yeah, you
homogeneous
have this
list.
thing in the middle. Like, it's not something that is totally reusable, right?
No, wait. When you have an arrow star in the kind one, don't you have also have this?
Consider the arrow
Oh, and
an
in
element
this
of the
time,
list,
yes.
right?
Consider the arrow one element of the list.
Right? So the arrow
And
is
then you
one
could,
thing.
yeah, and then you could pass the constructor of this list thing. Like, okay, I am expecting a list and a parser for like many,
No,
blah,
wait.
blah,
You
blah.
guys are not getting it. But what I'm saying is, the application applies on that abstraction, right? The list of something because it's a list of expression, like from the first
Mm-hmm.
to the last. But
Mm-hmm.
those ones that have the arrow not really fitting on that abstraction, right? Because then it's not a list of type delimited by parentheses and spaces, spaced with white spaces. Because the first one, it's a weird thing. It's the arrow, right?
Yeah, but couldn't we embed? Because you said, oh, it's a
We could.
list
We could
delimited by
do an
parentheses.
application, an abstraction exactly for that. We could for sure.
Oh, okay. So we would call this an arrow list, I guess. Because then we can embed the arrow like just as a parenthesis in a white space. It is composed of a delimiter, a white space, and the symbol arrow, right? And the symbol arrow, that's important. And then, for instance, when you have the bunch of t's in line 10 of the functions, let's suppose that you have 5 here, right? You have 5 t's in the for all type signature here. Then this will be the normal list, right? Because then we don't have the arrow embedded with the delimiters. Yeah, yeah, that's a possibility. So you would have to have a list and an arrow list.
Hmm.
But now the problem is, how can we like the first thing that I thought was, okay, let's suppose that I want to do, we're gonna embed this, and what changes? This change because sometimes it's gonna be for types, and some other times will be for for kinds. So this is gonna be another A, which we are passing here. But we also have the return, right? This other thing here.
Wait, can you go on the markdown file?
The markdown file. Markdown file.
Yeah.
I'm confused.
You
Which
mean
file are we
the
talking about?
README? There's
Yeah, the only
nothing.
Well,
markdown file you have is a README.
oh, okay, sorry. Org. I forgot you guys. I
But
using
which
org.
org file?
For
Yeah, which
the
one?
our concrete syntax, like the examples, right?
Oh, the function? This one?
This?
Uh, yeah. Oh, okay, yeah. Then you can use the list there, like right inside there, like after there, right?
You mean here?
Like yeah, exactly where you are, right?
Oh, okay, that makes sense, Nathan. So the arrow list is gonna have a list here or something like that. Um, yeah. So we have. Let's try to let's copy paste this example here because this is a good example, and put it down with us in the grammar file. So what we are trying to make, we're trying to make a parser that picks a delimiter, which is this.
Wait, can you follow Lem's like
Oh, you're watching via me, right?
Yeah, you are the one
we are
sharing the screen.
watching?
We are watching. You're watching me.
Okay, so as far as I can tell, this all of this thing, we are trying to make it like in here. That's my understanding. So this parenthesis, this is this thing. Then we have a bunch of white spaces. Then the arrow, right? More white spaces, and then we have the. I'm calling the list that we're gonna define here down here. Then we have a bunch of white spaces, which is this. Then we have this thing, which is the return type, right? Return. And in here it's a type. That's what I don't know how we're gonna reuse. Like make this reusable.
Like A, right?
Yeah, it can be an A, but then we're gonna have to do type a list for type and a list for a kind, right?
Huh?
A kind. So if you are a list of a type, then you're gonna be type args.
Wait. I'm not.
Kind args. Okay, so let me try to explain how you use this. I don't know how this is gonna be easier to read, but hear me out. So let's suppose that you want to use the arrow list to parse the arrow star, right? So instead of copy pasting all of this crap,
Like,
you're just gonna do arrow list kind done.
Okay, makes sense.
Why? Let me explain why. Because this kind will be replaced by this A.
I got it. Why? Makes sense.
No, but I'm explaining to see if
Oh.
Magetta have a problem also.
Oh, okay, sorry, I wasn't paying attention.
You see, not why I was
Hey,
repeating.
go on.
Anyway, Magetta, can you let's see if you agree. Do you see the piece of code here?
Yes. Type
The arrow
length.
list is an attempt to try to parse all of this just for types and for kinds, but reusing the same like delimiters, white space stuff. So what you're gonna do? You're gonna receive an A, and then you're gonna do all of these type delimiter, white space, all of that, and then you're gonna apply that A to the list, which have two sorts of pattern matching: a list with a type and a list with a kind. And then and then we can reuse here. You see kind arrow star like here.
Yeah, let's see.
We just and then the arrow for the type, which is this guy. We're just gonna do arrow list type. Done.
Wait, man, wait. The list type and the list guy doesn't make sense.
Yeah.
Why are you doing that? It's supposed to be generic, and it can be generic.
Wait, you're talking that the list, the list kind and the list type, they should be the same also.
Yeah,
That's what
you
you're
do
saying.
like list A, and then you describe a list in which you parse a list of A, right? Wait, by the way, can you put a parenthesis on the list A there? Because our like
Oh,
meta
here.
syntax parenthesis.
Yeah, meta syntax. Yeah, let me try. What happened to this piece of code, the kind args?
Oh, I deleted it.
Okay.
Although. Oh man.
Yeah, keep going. Yeah, keep going.
Okay.
Okay. Yeah. So what is the problem, right? We need to them try to make kind args and type args also generic so then we can have a list A here. And then all of this needs to be something like this. And Nathan said that we can. So let's copy this. Let's put it here.
Oh, okay, that is something to start. We don't really want a list, right? We actually want a non-empty list. Because the list implies that we can have an OR and empty list, right?
Yeah. That's why I made the non-empty args here.
Yeah, but I mean, if you are using list and how can I say? Okay, you are using the non-empty args, but then the list doesn't become a non-empty. Well, it become, but the name is like wrong, right?
Yeah, a little bit misleading.
But like anyway, we have like the delimiters that parameterize or not.
Yeah.
And what is non-empty
I'm removing
args?
the variadic. I'm also removing the variadic parts because we're not using
Oh, okay.
anymore.
Then you can just like inline the non-empty args and change the type for A, right?
Yes, you're correct. Then we pick this. We put it in here, but we put A here. And then you don't need this.
Wait, we had the optional stuff. Like, what was?
No,
Why
the
was that
optional
bad?
was because of the non-empty and the variadic. That was the relationship between those. Yeah, we
Okay.
don't have the variadic anymore.
We have the delimiters. Then we have a sequence of white spaces and what we want.
At
And
least one of these couples, right?
okay, at least one of those. And then
Yeah.
white space on the last thing,
Yeah.
right? Yeah, looks
Yeah.
right.
Yeah, now we can reuse list and arrow list all the time, which is great.
So let's try to do an arrow here.
Yeah. So, oh wait, now that we don't need kind args anymore, right? We don't need this kind args because it's exactly the list now. The arrow star is this, which is great. Let's re-add the parentheses here. I want to, before we go on, I want to remove the type variadic parts because we are using it somewhere. Oh, here.
Just nuke it.
No, we cannot. No. We need to pay attention on what we are nuking first.
Just remove it. Here, type args.
We have some special.
Okay, it's here. Here, okay, we can remove those. The type args doesn't make sense anymore because
Wait,
the type
dude,
args are.
didn't you just remove the line that has the commercial in it?
Yes, I
Yes.
removed.
How is that abstracted on the things we just did?
We don't
What?
because don't have the e-commercial anymore because we don't have variadic crap.
Oh, okay. So what's just like outdated? I forgot.
Yeah, it's
Yeah.
just outdated. That's why we said 90% of Silverware. So as far as I can tell, type args is exactly the same thing as list. Yeah, it's list of type. List type. Which means that we can nuke type args. We can nuke non-empty args.
Dude, but that's
This
like
arrow.
that's
This
type
arrow is already wrong. Yeah, arrow list with the type. Okay. So much cleaner, holy
Abstraction.
crap. The only thing that I want to be sure is that the parameters are correct. So the parameters, they are using left delimiter, white space, and then a bunch of typed parameters. The type parameters, they have an identifier and a type. Yeah, this is correct. So this stays. This stays. Yeah, I think we are clean now. I think we can go on.
Can you add the end of line on the file part?
On the file. Oh, here. EOF. Well, I'm not going to define that for now. I think it's already
You
good
don't
enough.
have a way.
Yeah.
Anyway, so now, okay, so we do now have a smaller-ish grammar. Yeah, it's smaller than before. It's easy to read. Let's continue trying to make the grammar for kind. So a kind or is a kind star or it's a kind arrow star. A kind star is basically
Yeah, I'm thinking about this. How don't we mistake this with the operator, like a variable? Because then it would be pretty bad.
The
Like you have to
context, I
remove the
guess.
variable.
the
Yeah,
Nathan
okay.
said the context.
Yeah, like if it's inside.
Oh, it needs to be inside the delimiters. Yeah.
Yes. No, not only the delimiters, right? But inside the arrow kind.
Yeah.
Sorry, inside the kind delimiters, like.
Yeah. Yeah, it needs to be inside a kind context, let's say.
That's still not that easy, I guess.
Wait, just a second.
I think we can fix this by precedence.
Yeah, probably we can.
I'm
Probably.
back. What is the part that is not easy?
I
Not-
think
Go, Magenta, go.
I just think about like if precedence would fix this because dude, like think of syntax. Like
Magenta, the way to say it is that they don't appear in the same kind of place, right?
yes, I know, yes, that's a problem. But how do we distinguish that by the
No,
context? That's my problem.
That's not a problem. Like it works like by default.
Yeah, one of them
I
you're
wanna
gonna be
see,
doing like
man.
this,
I wanna
and the
see.
other one you're gonna be doing like this.
Oh, we can.
So yes, it's by.
Oh,
yeah, so
sorry, it's not
it's
this, not
only-
this. I'm dumb. It's this. This. Oh my
Yes,
god.
so-
Oh my god.
I love this.
Magenta, let's use a case that we already have. How
No,
does it
this is
confuse?
fine. That's fine. Like it's exclusively under this, so we already know the
Yeah.
context.
Yeah, but oh my god, people will kill us. But they do have they can make functions with emojis, so they will say thank you after.
Can they?
Yes, they can.
Really? Did you try?
Because we dedicate one session just for emojis.
Wait, I wasn't
Yeah.
here.
Dude,
You were.
you were one of the culprits. Why we spend so much time on that crap, man?
Man, we haven't finished that. It wasn't working.
It
No,
was.
it was working. What are you talking about?
It
No,
was the
wait,
only thing we
Can you
did in a
show me
session.
that right now working?
Oh man,
Yes.
let's finish with shit and then we
Yeah,
we
let's
go
finish
there.
the grammar.
Okay.
So let's do a generic arrow. So the generic arrow, where is it in the grammar?
here. So this is
No,
the one
the
that you have.
generic arrow list here.
Oh yeah, here. Sorry, that is the generic.
Use some spaces, man.
So let's do that crap. Uh,
Yeah, so let's
let's
go
see.
to parser, the parser
So
folder,
type
and
last
let's go to.
delimiter.
We're gonna have to create a new file, I guess, called kinds.hs.
Let's do it here and then we just share the code there.
Okay.
So in between, because that's the most useful parser we have here. This is the same thing, I guess. Let me just see if my Emacs key bindings are working. Oh, they are. Awesome. Okay, so between
oh, okay, you're using this to make that. Okay.
yeah. So between this thing, we need to do the thing for the arguments, right? The thing that will come.
Man, we already
After?
did this. Where is that?
Yes, I'm looking here.
literal. No, it's not literal. It's expression. It is expression for sure. Oh no. Wait.
Archetypes. Archetypes.
You know, it's
Hmm.
types.hs. It is in this file, indeed. It is in here. We already did this at some point. I don't remember where. Oh man, not having highlighting is terrible.
Oh man, yeah, I coded without it for 2 months. What are you talking about?
I don't have highlighting. Oh no. Uh, man, I am
Okay.
100% sure that we did this thing before.
Yeah, I'm looking if it's not the same code we have here.
I think it is. I think this code that is commented out, I think this is the code that we were using before.
So let's see.
And it
here.
has here. This is the arrow with spaces.
Mhm.
This is the between with the parentheses. And then we have a bunch of many ones. So this is the plus in our meta language. But instead of type P, oh god, we're gonna have to do the either crap that we did last time around with the.
Oh wait, no. Archetypes is literally anything that is either a type or
a kind. Yeah, we're
And
gonna have to
but
use
then
the
we need to
alternative.
pass, right?
No, you don't have to pass. We don't have to pass. But we already did this once when we were parsing and
Just redo it. Just redo it.
Wait,
Just
wait.
redo it.
Why is the either thing?
To return.
Okay, so yeah, to return both a type or a kind.
But that doesn't happen.
Yeah, that does happen. We only have 2 cases of this parser of the arrow.
No. Like, it doesn't happen for you to
Oh
have,
no, to return this thing, yes.
like,
No, it
both
does.
at the same time. It doesn't.
No, it's not the same time.
Then it could be a parameter, right? Instead of this thing.
No, this is this or this.
Yeah, either is this or this.
Okay. What I mean is, we did that on the other part because at the same time it could be one or the other, right? But there it's either a list full of one or full of the other. So why not to receive a parser as a parameter to use it, right? Then we like get rid of a bunch of problems with either.
We're talking
Oh, I
about
see what he means. I see what he
deconstructing.
means. He means doing like this.
Yes, I got it.
You do a parser tst a, I guess.
Dude, what the?
I don't
Yeah.
think you need to do A, right?
No, it needs to be polymorphic because we need to accept both
This
a
library
kind and a
is-
type.
No, okay,
Right?
okay, makes sense.
And then we're gonna receive this. So this
Dude, the
parser B.
signatures are horrendous,
Yeah.
man.
They are
No, it's fine. It's totally fine, people.
No, it's not, man. It's very
not
It
at
is
all,
fine.
dude. Like that.
Dude, I feel like,
What is wrong with this type signature? Can
Dude,
somebody tell?
that's
dude,
like
what
the
is
API
ST? I
of
don't
a
even know.
Like,
No,
Yeah.
but this is because but let me clarify that. This is because we changed from artoparsec to parsec because we want
Dude, no,
It
some.
doesn't justify, man.
dude, yeah, it doesn't justify anything. Like,
What we are saying is, if you have a library, then you expose like a nice API, not your internals or some weird shit, right?
yes, exactly. Anyway, so let's
No, I'm
do
saying
here
that
the
because there is a chance that we
args.
are misusing it.
Oh,
Of
there is
course,
certainly.
also it's a high chance, but
So what do we take on many?
Many
Many one.
spaces p. Many and then spaces like this, spaces,
Mhm.
this,
Okay,
oops,
and then
this
P, which
p,
is the parser.
which is the parse
Okay,
that you're gonna receive here.
and this thing we get the return type, which
My
is
God, it's this
also
code, man.
something called.
It's
Yes, it
totally this
is.
code.
Yes, it is the same thing.
But instead of p,
Why is it
type
commented?
because we were. I don't remember anymore. I'm not gonna try to make excuses. I don't remember anymore. But it just uncomment this thing.
We're just dumb, man.
I would be very surprised if this type checks in your stuff.
I feel naked outside the max.
Curried arrow. There's something called curried arrow.
Oh, I remember because oh man, for making the signature, we only our arrow thing only has support for like one thing at a time, so we have to do the fold.
Yeah, but that shouldn't be a problem at all. Why is it complaining here?
Fold for all. Ooh,
folks,
couldn't match type A with type. So there is a mismatch. Okay, here, right? So we can make it
Oh,
generic.
okay, yeah. It needs to be other stuff.
hey people, you see the
Go.
arcs?
Yeah.
The arcs is the part that you're going to abstract. Like it's exactly the list parser, or at least the non-empty list parser. You just need to abstract the P, right?
Oh yeah, this is Nathan's correct. So let's copy this. Let's make another function called list. Oops, I'm not in Emacs.
I know
List.
the feeling.
But there could be very misleading because in the future, when we are parsing like lists
A
in
la
the
proper
objective
list.
language, yeah, that like should be also have the case of null. Then this is
Okay.
like fucked up. We need to be
Yeah, list.
non-empty list, man.
I'm gonna call it list P for parser because we have this convention already.
And what is the name of the other list that can be empty?
No, it's gonna be just the list. The when you are parsing the
But the other
list,
is also generic. Oh
that
wait.
doesn't matter.
Uh, okay, just finish. I have a question up here.
Okay, so many one. It's probably complaining about. Uh,
Let me do a. Oh man, let me do an example here.
probably complaining that it should be like this. Yeah. Okay, so the args instead of args is gonna be list p. List pp. Um, yeah, I think this is the arrow. I think, and this is the list parser that we just did. Yeah.
Okay, so we have another problem on the curried.
What is the code problem?
Is that you see the return? Like this thing is a T arrow,
Yeah.
which implies that this A is not generic. It needs to be enforced to a type.
Oh, it's because the types.hs AST, if you go there, types.hs as outside from the parser, right? If you see our data type for types, the T arrow only can only receive type. You see?
Yes. We don't have no. Yeah, but here's the thing. The kind is another thing, right? We shouldn't put kind here as well, like either this or the other.
Oh, it is because it's
So
an arrow K when it is a kind.
yeah, so here's my question: like, can we match the type of a like this in F sharp, for example, like ABC, and then if it's an integer, we do this. If it's a string, we do this.
Wait, why would we need that?
Oh, to
Because
change this
sometimes it's
arrow.
gonna be a T arrow and some other times it's gonna be an arrow K. And there is a way of making what you said, Mageta. which is to make a class, right?
Arrow. What is
So
with
we could,
arrows? Oh,
Like could be TROK, I think. No, it's not okay, right?
yeah, arrow K and T arrow. The arrow
Yeah.
K is for kinds and T arrow is for types. Yeah, so we can make a class for this. So what is a class? It's basically a type class, but we define.
Okay. How do we do that?
I don't remember anymore because there's been a while since I did that.
like,
How
are
can
you
we?
sure isn't better to either like being generic? What could be weird, right? Or just receive as parameter which one it is?
We can make as a parameter, but I think would be a very good use case for making our own class, because then we can just say, oh, the type and the kind, they are curryable. Let's create the curryable type class. And if they are
Oh,
curryable, that means that we can just call it here instead
Yeah,
of
it
doing
makes sense.
arrow K or T arrow.
but doesn't that do for the whole type? Like for the type kind instead of the arrow K?
Yeah, that will do
Uh,
it for the whole
Then you
type,
could
right?
pass a
that
star, right?
then you could do what?
Then you could pass star K.
Then you could pass star K. Star K.
Since you are
No, no,
doing
no, no.
a
Wait. No, let me explain better. After you define the class, we're gonna define the function that you need to implement in order to have that type class. Okay. Then we're gonna define the implementations for this type class, both for the types of kinds and for types of types.
Dude, I know a pragmatic solution to solve this.
Oh yeah, there's many parametric solutions for this. Of
But
course there
anyway,
is.
let's do the proper way.
Yeah, I think this is a good use case. Maybe I'm wrong, but I think I am right this time. Let me just see how, because there's a fair bit of time since I did this first time. Oh, here. No. How? Oh my god, what a clickbaity website. Oh, here. Okay, so it's like this. So I'm gonna go to the code. So that goes to types.hs in outside of the parser. And let's make a class
Wait,
called
where are you? Let me see.
types.hs.
Okay.
Curryable. Curryable. And
Isn't it
then
with wouldn't it be like curryable like this? I
I'm
don't
not
know. I don't
no.
know. I know I'm not an English speaker, so who
Yeah.
cares?
So um, we cannot call it curry, unfortunately, because this is already taken. Uh, I don't know. I'm gonna
This
call it compose for now.
curry with a K.
Curry is okay. That's not the worst.
Yeah, because
Curry.
you can curry kinds, right?
Yeah. Then um,
Oh,
then what I
man.
think we need to do is instance curryable
Mm-hmm.
type where curry is equal to t arrow,
Okay.
and then we do the same for kinds. I'm actually gonna put this. I'm gonna put this up there with the kind. So kinds. Where's kinds? So here. So it's gonna be around here, and then in here we do kind, and I'm gonna say, oh, when you have this situation of calling this is gonna be arrow k.
Wait.
Okay.
Follow you.
Now we save it, and now we go back, and do you see this carried arrow? Now in this has a constraint,
Okay.
which is that the A needs to be curryable, right? And then instead of arrow K,
We need to import that.
yeah, we do. And we need
Okay.
to export that also. So do the import, I'm gonna do the export. Uh,
This.
I okay. Let's do the easy way because I don't remember how to do this properly. So like this. Everything is exposed now, and we import everything here.
Awesome.
Okay. Okay, so is it complaining now?
Let's see. No, it is not.
Okay, so it worked.
Okay, I like this. It's very elegant.
Did you understood? Did you understand, Nathan, what I did? We did
Yeah.
that. Okay, so do you see that although we have more, like the type, data type has like t unit, t integer, that doesn't matter because we define what is gonna be the one responsible for currying.
Uh-huh.
Mm-hmm.
Yeah, that was a very good use case for it. Okay,
Okay.
so now is the arrow parser doing okay? Oh, we have shadowing. Okay, so let's call this arrow p.
Yes. What is
Okay.
he complaining here, man? Defined but not used. Curried arrow.
Oh, it's
What?
because no, we are using
We
here.
are
Right?
using here.
Oh yes, you also need to add this constraint here.
Oh, to be curable.
Yeah,
Mm-hmm.
yeah. I think that I'm not understanding why the
If you
curried
don't
arrow.
put it, I think it infers, right? Let's see.
Yeah, it should infer.
Uh,
It should infer.
yeah, well, it gets from here, so probably it does.
I'm trying to understand. So it's not complaining about the type arrow. You see here?
Wait, which line you are?
I am
This one?
in. No, I am in this folder. In this
No,
folder,
no, I see.
line 12.
Wait, 12?
Yeah. You see that the type arrow is
Oh,
now
yes, I
complaining
do.
for some reason?
Type
Yeah, so we need
arrow
to discover why.
parsec char st functor blah blah variable not in
Oh, I know
scope.
why. I know why. It's because the name of this parser before it was type arrow.
Oh yes, that's true.
Okay.
I
So
just
type
removed the
arrow.
type because it's misleading, right? You're
Now it
doing
is, so we should change it.
yeah.
So arrow p,
And then
arrow
here,
parser, and then in here we just put arrow p type. And just go for it. Just go for it.
oh, it's just p, right?
No, it's not p
Oh,
because that's a
p type.
function. Yeah.
This.
Yeah, but it is still kind of wrong because it's expecting a type, right?
Oh,
So
that's stupid. Sorry.
it's
Type
type
p.
P. Yeah.
Yeah.
Okay. Do you
Okay.
have any other complaints in this file?
I don't think so. Just these, no kind star, but they are undefined, so that's
Oh,
fine.
okay.
Let me try compiling this.
I'm gonna be very surprised.
Let's see. Okay,
And
it
oh, it
did compile.
works.
There's just these instances alone import foreign. Okay, never mind.
Yeah, I don't know. I can tackle that later. That's
Okay,
not a
let's
problem.
do the for all already since we are here.
Yeah. Okay. So, oh no, let's go to our parser.org and
Oh,
let's put kinds
actually,
as done.
yes, actually, let's add it here. We forgot about the arrow p kind. Actually, kinds is not done, right? Because we didn't do just the star.
Oh yeah, we need to do that. So, but that should be very fast. So kind star is just a string. It's gonna be star k.
Mm-hmm.
This no, not this. This string this. That's it. Um,
Actually, it should be kind, right? It should be a parser kind that gets abstracts either one of those two, right? So we gotta do those specific ones, and then we do another one with just
oh, you mean about the one that sums them up?
yeah.
Oh yeah, that you're correct. And then we need the arrow k, which is gonna do which matters the so it's a full f map. And then we do arrow p
Oh, I see.
kind,
Mm-hmm.
and that should be it. But now we need the kind parser. Parser t st kind. So the kind parser will be either a kind star.
Mm-hmm.
Oh, we should do the other way. That we didn't actually tell Nathan about it. That for some random reason the alternative is broken.
Oh yes, that
We
we
should
need the
tell him at
choice.
some
Oh man,
point.
yes.
we
I don't know,
discovered
dude.
this by accident.
Yes, this was totally accident.
What do you mean by that?
We were trying to do with the alternative, but then we discovered that this is broken because this
Yeah.
is like what we should do is not consume the inputs, right? But it is consuming. So
Yeah.
and then I said, okay, let's try to use this try, which is like it doesn't consume, and then we just fmap the list and then use this choice.
And was that on the docs for the operator?
What?
I don't remember anymore. Let's just fix the kind arrow because I'm doing something wrong with it. Because it's saying, oh, I couldn't match this, blah blah blah. Oh, it's because, oh, I know. Wait. Oh no, this is wrong. This is just this. Ah, cool.
Oh yeah, the arrow. Yes, that's where.
It's
Okay.
already curried, right? So I don't
Yes,
need
that's
to
true.
care.
But here we gotta change, right? It's not oopsie. I'm still following you. Up here is not this, so it is just kind.
Yeah.
P.
And let's make the
Or is it just kind? I don't recall there.
What is PEP, man?
P, the capital P is for parser, right?
What is
But the
PEP?
PEP.
Wait, PEP, where are you
What
guys
the
seeing
fuck
that?
are all those PE? Man?
Yeah, I think. Yeah,
No,
everywhere.
it's the
Oh,
horizontal
type.
bar.
Oh man,
Oh,
yes. It was like
Holy
this.
crap!
It was like this. All right.
PE liter.
So, but here's the thing: like, it should be just type P, right? And kind.
No, it's not the same. It's not the same because the arrow type P, it's saying that we have an arrow that has the. We can have arrow kind.
Type P.
Yeah, we can have arrow.
But
Wait.
we can have just a normal. It should be arrow.
Wait, folks,
P.
why is kind inside of types?
Oh yeah, that's
Uh,
true. That's true.
okay, that's the problem. That's why it
Yes,
was so
that's the problem.
confusing
No, but dude,
before.
it should be just. It should be. Wait.
No, it should be like
Oh
this. It should be
yes,
like
there is
this.
an arrow.
We have
Yes.
a literals, we have arrows, we have for alls, and we have type variables. And now comes the second part of fancy stuff, which is that right now we also have the abstraction and the application.
Ooh.
Yeah, so this is the second part of fancy. So these are the types that we are missing. If you go up there, Magita, on your screen, on this file that you are right now. These are the ones that we need to define next.
By the way, shouldn't we make the? No, never mind. Okay, so just the T abstraction and the
Yeah,
T
while
app.
you do that, I'm gonna make a file for the kind parsing because I
We
don't want.
didn't. How would be the
Wait,
syntax to
application
identify
is
them?
already done, right?
Application is already done.
Is
No, no,
it?
no, no, no. We don't have application done. We have e-type application done, and we
Uh,
have abstraction done. Yeah, if you go to expression.hs, Magita, if you go there,
This one.
expression.hs.
It's
So
type.
we have a discussion in line 18 on line 18 that this file that this parser is actually complying two different parsers, which is for type for the e-type application and the normal e application.
okay.
This. And then we discussed about doing
Oh
the
yeah.
same thing for abstraction, and we didn't do it. And then we started doing the expression e-type abstraction right here that is commented out. But this is when our brains totally fried, and then we stopped.
But you said there that we needed E-type abstraction and E-type application, right?
No, the e-type application is done.
Oh, okay.
I said that we need the application and the abstraction.
Oh, okay, the
Yeah.
new one, right?
Yeah, the newest, fanciest ones.
Yes, but these. Ooh, I'm feeling the pain already. Let me put it here. And here. Oh man.
I mean, it's pretty much the same, right? But maybe the casing is different, probably. And instead of types, you have kinds, right?
Yeah, that's true.
Yeah, so we can just kinda copy paste.
No, thank you for the pun.
Like, you didn't want to say it, right?
I bet he was waiting for the right moment to say that. Dude, I don't know. I feel dumb being Haskell, man. I
It's
think I
because
need to
it's not
do
a language that you
something.
know, man.
I
That's
feel
it.
like, but dude, like if I okay, like it's not the same thing as speaking like I don't know Go. That is just like the ceiling of Go is just small.
The ceiling of
Yeah.
Yeah, it's totally different than Go in this case.
Oh
Kind.
man, let me see where you are.
I'm making things a little bit better here. Uh, done,
Okay.
done. I don't know which things we.
This one we're not even using this, I guess.
Yeah, we are not. But I noticed a thing. Um, okay, so this is wrong. This shouldn't be here. This. This should be in the Nathan's favorite file, utilities.
Oh, awesome! I love this file. We need to import curable.
Yeah, we need to import. Just import types for now. Later, I do it in the proper way. Oh, there's a button. Let's click the button. Oh, the host doesn't allow me to click
a
the button.
button for what?
Which
Yeah,
button?
you see that in line 15 on this file, there's a button called import types curable.
Oh, I see.
You can click that.
All right,
Oh, that's a nice
that's cool.
extension.
Now we do need to fix these betweens and chars and crap, which I basically gonna copy paste from this. Uh, wait, I did something bad.
Just type, man.
No. I definitely did something really bad. I removed the import that I shouldn't.
Spaces and just career arrow. Where's career arrow?
Where is my? Ah, I'm breaking stuff.
Where's career arrow? I think we left where?
No, current error is in here, man. It's in utilities. I just copy pasted. Wait, current error you
No,
said?
it's not in utilities because it's
Oh, so
complaining
it's
here.
here. No, it is. I'm gonna put in utilities at right now.
Okay,
Yeah, it's this.
curry with
This.
a K. I love it.
Curry with the K. Well.
Oh wait, we need to import
Yeah, we need to import. That's what I'm
curry.
trying to figure out. Oh, I found it. It's this.
Let's
We need
see.
to import this guy. This guy. Text, parsec, stuff. It's already there.
Yeah, I added them.
Okay, so what else? We need to. Oh,
Curry.
it's still complaining about curry. Um, I don't know why though, because you already imported the curryable stuff.
Yeah.
Arrow P, list P, and then in the types.hs we just import it. Import utility. Oh, it's already up there. Okay. Then we put arrow P here. What is it complaining? What? It's because it's also in here. Okay. We don't need that. We don't need that, and we don't need that. Okay. I think that the types.hs file is done. Now let's go to the kinds.hs file. Let's import the arrow P. Cool. And yeah, done. Kinds are done. Parsing kinds.
This type variable generic is redundant. It's complaining here. Yeah, who cares?
Yeah, later I can figure that out. That's no problem.
We can
I'm
fix
trying to
that
understand
later.
why the
Nothing
curry
urgent.
is it complaining, man. It's still
Oh, let
complaining
me
about the
see.
curry.
Variable
Variable not
not
in
in
scope.
scope. Yeah.
What the heck do you mean? Okay, so let's remove this for now. Accept as it is.
Yeah.
Okay, so now we can go back to where we were.
could it be this? Oh yeah, now it's accepting.
Oh,
Like,
now it's also importing the functions from the type class, not only the type class itself.
yeah. Okay.
Okay, so now that we have this separated, where should we go?
Let me see.
We were doing something. Oh, expression. We need to
Let
do
me
the
see
E
if
type.
this is still compiling. Oops.
Okay.
I think we need to go back to the grammar, man. Because we probably don't. What the?
PowerShell. PowerShell. No complaint.
PowerShell. And I'm expecting it to break.
Don't trust in yourself, Lemos.
Well, I'm not in Emacs, so. Yeah,
Alright.
it
It does
works.
work.
Let's go back to the grammar then. What do you want to tackle
Like
here?
one of the things that you have to do eventually is the T abstraction, right? But you,
The abstraction, yes, we will.
so we
Mhm.
probably don't want like inline lambda for the user to write because it misses the whole point. Because what is the thing that the T arrow gives you? Like it gives you a way to parameterize a type, right?
Yeah.
But that's the thing. If you cannot reuse this type with a single name, so if you don't have things like type alias, right? Or a type declaration, it's kind of the same. If you don't have that, then there is no point because every time you need that arrow applied to something, you have to write the whole thing. And if you have to write the whole thing, why is it parameterized then?
Yeah. So how should we tackle that? So the problem is, Mageta, that Antan is
Yeah, I
explaining.
get it.
Okay.
I got it.
Okay, so how are we gonna tackle that?
That's
So
another
we
whole
can do
different
like
question.
people do, right? Like Okama and Haskell, you have a type declaration stuff. And that will create your T abstraction.
Can you repeat that last part? Type.
Yeah, we can create a type declaration or syntax, right?
Hmm.
And that could be to create the T abstraction.
So to make the T abstraction, we add
Uh, so you see your type parser T,
parser T.
like line
Where?
19.
19. You're talking about the file. I was in the grammar. Okay.
Oh yeah, the left
Oh.
one, utility.
Oh, utility is 19. Yeah, I see that.
So that is creating a T abstraction, right?
Yeah.
So yeah, we can do the same.
Um. Yeah, but But how are we gonna do that in Silverware? We need to think about how to
Well,
mimic this
it's the
behavior.
same, but with S expression.
It is the
Let's see.
same.
Let's define here. So how would that be?
Like the file.
Yeah.
You start by the file. The file now it's like a list of stuff, right?
It's
So
like about this, Maggot.
Yeah.
So it's a list of stuff.
so
So it's
that
a list of what
stuff
stuff?
could be declaration, for example, right?
Declaration. What is a declaration?
Wait. Uh, we need to put like white spaces, right, on that list, I guess. And we also
Yeah.
need the end of file anyway, right?
Yeah. UF.
I think this must be plus.
And then one before, I guess.
Y
No, but
plus.
the one before needs to be star then.
No, before like outside the group, and it is star and not plus.
Yeah,
Where?
this plus here is weird.
Yeah, every
Oh,
plus
we
there
have
is a star, I
brackets.
guess.
We have brackets, so this can be like this. Yeah, it can be like start like this also, but it's kind of weird. Like you're gonna try to compile, interpret a
An
file with
empty
nothing.
file.
Well, you can, right? You can.
You can. But
Okay,
yeah.
that's fair.
So yeah, what
What is
could
a
be
declaration?
declaration? It could be like either a value declaration, like a top level declaration, right? Or a type declaration. It could also be just an expression, for example.
So wait, you
Mm-hmm.
said that it can be an expression,
Not
or
necessarily,
No,
right?
no, no,
If
no,
you
not,
want to.
not. Yeah.
yeah, no. Let's put the possibilities here and let's exclude as we go. So it can be an expression. What else?
type declaration
A type declaration.
or a something else declaration, like value. I don't know. Like,
A value declaration.
yeah, if you have a better name for that, please.
Okay, I'm gonna change this to a global value.
That's worse. That's way worse.
No, that's better because now it has better
A
semantics than just
global
value
value.
declaration. Type declaration. What is a type declaration? A type declaration is or an ADT or
Yeah, there we can make some stuff, right? So, for example, we can differentiate, for example, between the things that will be alias and the things that will be like declaration of either a record or ADT, right? Because
you also have records.
we,
But you said type abstractions here also.
uh, no.
What wasn't you saying about doing? Wait, I lost the copy paste. Wasn't you talking about replicating the Haskell behavior of doing the type abstraction?
Yeah, but what it means is that they implicitly generate a type abstraction, right? So they are still an ADT or record on a ADT, right?
Oh, implicitly.
It just happens that if they have a list of parameters there, then we do that thing with default, right?
Yeah.
So yeah, what do you guys think of that? Like,
I found the perfect syntax.
No,
but you're
Mageto's word
right.
being creative.
Oh yeah,
I
actually we
think
have to consider the concrete syntax. That can change, like if we need a different keyword or not.
Yeah.
But yeah, for
I
example, what do you guys think of separating, at least on the AST, I guess, what is a type alias, like a normal one, and what is a type declaration of either a record and ADT? And I say that because of that thing of kind inference, right?
yeah, but I think Mageto already considered that because as far as I can tell, this is a type alias.
yeah.
Yeah, but that's the thing. Like, I think they are independent, like our representation of the syntax. But yeah, the syntax can also be different.
Oh, you're talking about okay. So the representation the ST can be separate, but I would also argue to make them separate syntactically.
So okay, our def type. Okay, but we need parameters also, right? How would we do the parameters part?
Oh, good question. Like something that takes an A, right?
Yes,
Let
something
me
that takes
think
an
here.
A.
Yeah,
This is a good
list actually,
example.
right?
Let me think. Let me think. Just a second. Just a second.
I have a few other candidates for this. So, for instance, I kind of prefer like this.
That kills a bit of this expression, but we already have like curly brackets, right? So
Yes. Who cares?
Yeah, I also have these options.
wait, what the fuck is the last one, man?
Let me see. Okay, this or the other,
Oh, that's
right?
not for
Yeah,
types, right?
yeah, that's all for types.
Oh, what? Why do you have to? Oh, okay. Can you give some
Define
like
or
new
def
lines
value.
on the?
Yeah, let's do a new line here.
Okay, nice. Uh, yeah.
Oops. Yeah, def alias, I like it actually.
So we can
Yeah,
use the
but this
angle
is
brackets,
so F
right?
sharp, man. This.
So let me see. We can have this zero, like nothing, or we can have a list of things inside, separated by comma, right? I think that just works.
What about we just use the normal thing here instead of this curly bullshit?
Bullshit. And we are
Oh,
missing a
okay, because
bracket.
then we have like one element, and then the rest
Yeah,
is a list, right?
yeah, because if we start like just bolstering, actually it should be this, right, to be consistent. Like,
Huh?
yeah, one
Yeah,
list
this is
full of
the
things.
same philosophy of the let,
No. I
Nathan.
think that doesn't make sense because when is the rest, you already know like where is the list. When it's in the middle, then you need another wrapper. That's why
Wait,
the
can you
left
repeat that?
thing. Yeah.
Oh, yes.
So when you have the thing,
Oh, yes, but in this case, we can use the same thing as the what we did, right? With the arrow, we just changed it to a normal list.
I didn't understand.
No, what Magetta said is
Oh, I can
we
use the
can
many in
trans.
this way. It's the same thing. Like it
Oh,
will
you
not
mean to
be.
parse?
Yeah,
Yeah, it means to
Oh,
parse.
but to parse both
yeah,
are.
it will be the same thing. Yeah,
Yeah.
it doesn't matter.
Yeah, but I don't like the extra parentheses in this case.
Yeah, this is fine. I like this.
Yeah, this
Another
is really.
thing, does the C needs to be involved in parentheses?
Well, to be consistent, I would say
Yeah,
so.
I think it's prettier, right? Like,
Yeah, it is definitely prettier.
yeah,
That's for sure.
Yeah.
without looks weirder.
Yes, I prefer like this.
Why
Yeah.
are we using the off? Do we need the off, man? Like, I don't think we
No,
do.
we don't. We don't.
Yeah, we are
Or we
not
could
using that
do
in. No, but
off.
we are not.
Huh? Oh, you wanted to put prefixes?
Yes.
Oh shit, that's bad.
Oh my god.
Or we could use the cons thingy
Mm-mm.
like this.
Why? Why would?
Oh, I don't know. Just to
I want to
the
propose
dotted list.
to use the same philosophy that we used for before when we did the lambda. So if you go back to the, I'm gonna just copy paste it and place it there. So if you see this function here, where we were here, look, we were doing like that. I proposed the same philosophy. You see?
I don't actually.
Okay, like just the label and the type, right?
Yeah,
Oh,
the label and the
okay.
type.
You mean okay.
Yeah, which is what we are already using.
Hey,
Uh,
let's just like leverage
What
that we
about
are already
this?
on that and discuss something else. Like, do
What
we
about
have
this?
multiple types on a case of an ADT?
Multiple types?
of a case of an ADT, I
Yeah,
don't.
because if you
What do you mean?
have multiple, then you can like partially apply them, right? Use them as functions
Oh,
and such,
okay.
like
Let me
in
think.
Haskell, basically.
No, like in
Mm-hmm.
Haskell.
Like in
That's be really
OCaml,
cool.
yeah, because in OCaml you can't use the thing as a function. It's a pain in the ass a lot of times. But being a
Yeah,
function and having multiple parameters, they are
like
different
piping
things, right?
something. Yeah, like piping something to some stuff like this,
Yeah,
right?
we can in F
Yes.
sharp, right? But
Yeah.
so we have three things, right? Like F sharp is the middle ground. You only have one parameter, but you can apply it as a function.
Yeah.
OCaml you can't, and Haskell you can do every shit. Like you can have multiple parameters, partially apply it as a function.
Yeah. Yeah. I would, of course, cheer for the Haskell way because it's so convenient.
I think I would go for the Haskell because it's like fancy.
Here's one thing about against this alias, I think. I like it, but I think we can keep both actually.
But I don't see a point on having both.
Documentation.
Huh?
Because, well,
Documentation.
readability. Like you're reading the code. That's it. Like Lisp does this a lot. Like you
No, no,
have the
but in
functions
Having
that do
terms
the
of
both
same
doesn't
thing.
say
readability,
that.
no, I don't
Good
think
naming
No,
and
no,
having
no,
both
no,
convention.
improves
no, no, no.
readability because alias is just much better than in the type,
No,
def
because
type.
here's the difference. Like, let's suppose we have records, okay? I don't know the syntax, but who
Yeah.
cares?
Yeah.
Like,
Okay.
and then you make this, let's say. So
Yeah.
this is a
Okay.
record that picks this shit. So
Yeah.
this is a definition of a type, right?
Okay.
But then, like, okay, the alias, it's also an alias for this, right? I think like something like F sharp. It's like for this generic thing, right?
No. But Nathan doesn't want to treat records as just an alias to a product type because it sucks. He wants to make like proper records or something like that.
Oh, this is
Wait.
not.
What are we talking about?
We are talking about
Uh,
maintaining both approaches of having the def type and def alias because I suggested to add to instead of using this, use this.
Yeah, what that
no,
means? Are you guys talking just about the name?
yeah. Basically, I'm just
They
saying
are
like
doing the
we should
same
keep both
thing?
because yes,
Yes.
because here's the thing: you cannot define what is okay. What is an alias? I don't know. Like, how do you gonna define that this thing is an alias? That this thing depends on other types. Anything, any type you're gonna define will depend on other types. So it's also an alias.
Uh,
So you see my
Okay,
point?
that argument is fair. I would say that the argument is fair enough in
Yeah,
order to
but
make like
it's easy
this.
to distinguish. Like the
No,
parser
no, no,
does
no,
that.
dude. But here's the thing. Like, I'm not saying we should get rid of the alias. We can keep it. Like, Lisp does a lot of, like, you have the same thing that you use in circumstances to improve readability. Like, this is one case.
Okay, so let's do the following. For now, let's just ignore the alias, and let's do it just like this, and later on we can add this.
Yeah, let me
Uh,
just say my point.
But this is already doing it. It's the
Go,
same
Oh,
Nathan.
thing.
you are
You want
commenting
to say
Haskell,
something?
dude. Or is that our
Yeah.
comment also?
No, that's I'm commenting in
Okay,
Haskell.
my point is that I think we should do the internal representation as separate things, because then we gain like kind inference, supposedly, if we manage to implement it, right? Regarding the syntax, I don't care if like both alias and declarations have the same name, but I do think it's weird if you have like def type and def alias and they are doing the same thing. Like,
Oh, but they do always the same thing.
what is the point of having like an operator like plus that
And
does the
add.
sum, and
Yes.
also like plus plus that does the same sum? Like,
Well, those are two different things. I'm saying.
no. They are the same function. They
Oh,
only
yes,
have.
but why would you do two different things? You're not improving anything
Yeah,
on
that's
doing
what I'm
plus
saying.
plus.
Isn't that's
But
what you're doing?
Magetta is saying that we are improving something.
How?
He's
Well,
arguing that this improves
readability.
readability.
Yeah, you are
But
basically just
readability, it's
remapping.
basically choose the one of those two that is the best, and not having both. That's confusing.
No, dude, it's
Um,
about selectively choosing which one is the best for the context you are in. Like,
yeah,
for example,
that's about readability, Matt. He's
if you
right.
do def
Yeah,
type
but then you
here.
should limit with which one can do.
No, dude, let me put my point here. So you're doing def type. You're also defining a type ABC that is integer. But you know this is just an alias. So this is an alias.
Yeah, I guess our
This,
definitions are different then.
you're defining ABC that is this record. This is also an alias. But you're not going to put it alias here because you are declaring a more complex type.
Yeah, okay, so let me give you some context. Like, you see that in Haskell, we can't do, like, let's call it inline typed for records or ADTs.
Can you repeat that? In Haskell, we can't do inline ADTs.
Yeah, you can't do like, oh, I have a function that receives a type, and that type, it will be a record, and then I just like type the type of the record, not something that I declared before. You just type it there, inline it, right? You see that you can't do that.
I'm not understanding
Type an
the
example if
example.
you can.
Yeah, so you're talking that we cannot do wait. You cannot do a data type, I don't know, ABC. That is a function you said.
Okay, declare there a record. Like, see that data ABC, it's a record.
Mm-hmm.
Okay, ABC record. Ah.
Okay, now create a function that receives that. Well, you can create any example, like foobar on the record itself.
Foo bar. It's a function that
No,
receives
any type, like integer.
integer.
Now create a function, right?
The inside is a field of the record.
No, create a function in another line, like outside the type.
Okay. Okay, function.
Yeah, it receives a.
A.
Okay, yeah, the a that I mean was the label, but see the a there? That is the type, right? Can you
ABC.
just copy? Yeah. So now you are referring to its name, right? The name of the record, right?
Yeah.
Can you copy the definition and paste there?
Can I copy the definition and
The
paste it there?
foobar integer?
Yeah, that part.
This?
You can't, right?
No, but what does that mean? I don't even know what is that. What is that?
Just copy the line 5.
Okay.
And substitute in the ABC. No.
In the ABC.
For the
Yeah,
ABC.
instead of
Yeah. So you can't do that in Haskell, right?
Well, yeah,
Yes, you
you're
can't.
wrapping.
So yeah, that's what I mean by an inlined type, right? You can just like put it there without declaring first, right? That's where I draw the line between alias and declaration. Declaration, for me, it's only for records and ADTs because you can't inline it. An alias, you are doing that for a type that can already be inlined. Like when you say, oh, data name is equal to string,
Oh.
that's an alias. You're not
I
declaring
still
anything.
still didn't get it. Explain to me,
No, I
Lewis.
explain. I can explain. So pick something that can be an alias, a record, or an ADT, and then if you have a function that is using that. So let's
Hmm.
suppose that the name of that, whatever you chose, is ABC.
Mm-hmm.
ABC that does, I don't know, picks stuff and do stuff. Nathan said that if you can pick the declaration of it, what that means is basically what is after the equals.
Yes.
If you can pick that and replace it in here, then he would say that this is an alias.
Oh, okay, makes sense. Mm-hmm.
Otherwise, it's a record or an ADT.
Mm-hmm.
By the way, doesn't need to be that way.
Yeah,
Is
this
that
case.
way because we are using a like very nominal type system. Like things are not only how they look, but
And I do
also
agree, and I
This
do
is
agree
sort
with you,
of this,
Nathan.
right?
Yeah, he would classify this as a type alias because you can just pick whatever places that we have ABC and change that for integer.
no
Mm-hmm.
no no. He's declaring an ADT there, right?
Yeah, this is wrapping. This is actually I'm creating an
Oh, this is F
ABC.
sharp. Sorry, I
Yeah, this
saw
is F
the
sharp.
type and I
Oh,
put
Yeah,
Haskell.
this is not the same thing, right?
Yeah,
Because
this is not the same thing. This is not the same thing. So this is an ADT, so you cannot do that. But if you have, like, I don't know, an alias, then you can.
Mhm.
But uh, um, your point, Nathan, I don't understand why your point is clashing with what Magetta said. Because what
no,
Magetta said is that you should have, not you should, you can have both naming schemes.
yeah, I think it clashes on this on the meaning of what is it means to be the alias, right? Because his meaning is something that is that you can determine. On
Swappable.
my case, yeah, swappable. On my case, I can't. Like, I don't know what is the thing that is swappable.
Mm. Okay, yeah, that's fair. So there is the clash then. So yeah, so
by the way,
um,
I only really care about the internal representation. I just think it's weird. Like if you have two different names doing the same exact thing.
Hmm. Yes, that's true.
well, to
Yeah,
be fair,
I mean,
sometimes
I think
go.
it's like it's there's still the argument of reading, but
Yeah,
that
reading.
that
I agree with you, Magita. That, but I
but
think that that's a double-edged
But
sword
yes,
Magita,
because
that
if you
that's what I say.
start,
But no, but wait, that will depend on how you're gonna implement uh this alias, right? If the argument to do the alias is something like this, then I don't think it's a good strategy to do the same word
no,
because well
I'm
there is some behavior that is like expected on both. Now they have the same implementation but both can do the same thing. Like, that's kind of weird.
Magita,
no, but that's the thing. Go, Nathan.
why
Go.
don't we do the following then? We have that type, and we
Mhm.
use that for declaring records and ADTs,
Yeah.
and we have def alias, and that's for declaring like things that are not what def type does, right?
Oh, because def ADTs is already here.
Huh?
Yeah, it's
Oh,
algebraic.
okay, yeah, I forgot the thing. I see.
Yeah, but the double-edged sword is that I think it's a fair argument that although internally the implementation of these and these they are the same, when you're reading the code for mental human parsing, having a more semantic word as alias is better. But if you start saying things like that,
Yeah,
people
but
will start
if
saying, "Why
yeah,
not def x?" When I read def x, for me it's better. Why not def y then? And then you start bloating your
Ah,
language with something that is exactly the same but has a bunch of
by
names.
the way,
yes.
Lemos, like when we are like parsing the nodes, right? They are different things. because of the kind inference thing. But when we are type checking that part, we read through that part and that's something on the context. Both become type aliases.
Guys, I will just have dinner. I'll be back in like 10-15 minutes. Just a second.
So you see how it's a blurring line? Because the nodes will be different because we want to type check them different, right? Because of kind inference. But when we finish type check, both will generate something on the context. What both will generate, it's the same thing. It's a type alias.
Yeah, no, from that point of view,
You
it's
see,
kind
like,
of blurry. Yeah. Um, yeah, I totally understand that. But I'm not. I suggested the def alias, but now that I think about it, I actually it's like this is only for alias though. This def type because ADTs and records they will be using this notation. So I think we should choose one. We should not maintain both.
what is the standard ML approach, by the way?
Standard ML. I have no idea. So let's search.
Oh, I'm not seeing your screen, by the way.
Yeah, no, you're not seeing my screen, but I will. I will.
Copy
Well,
the
I can.
link.
I can share my screen. No, but I can share my screen. So I will share my screen. Here.
Oh, I just got some
Okay.
water.
Um, type alias SML. ML type aliasing. Oh, it's with the word type. Oh, so it is the same as in Haskell. Cool.
I'm back.
It is the same as in Haskell. You type the word type.
Oh, that's for alias, right?
Yeah, yeah.
And what about declaring the thing?
Um, okay, so ADT is SML. Okay, I found a PDF. Oh, here.
Data type.
Data type. Yeah, it's closer to Haskell than I thought. Okay. Or oh wait, should I say Haskell is closer to this than I thought? Yeah.
I
So I
guess that
think that
maybe it makes sense because the way I think about it is okay, data type, then you are also declaring like constructor stuff. It's not a thing that we only use on where you put types. It's also like declaring a way to construct, right?
wait, can you repeat that?
Yeah. So when you are doing an alias, you can only use what you got in places where you can put types, right?
You can only get what you got.
You can only use what you got
Use what you got.
in places where you can put types,
Yes, that's true.
right? But for ADTs and kind of for records, that's not true, right? Because you also have the constructors, the data constructors, right?
Okay.
So maybe I think it makes sense the SML way, like calling type and data type. But I don't know. Maybe I'm stretching too much on SML, like the hawk.
Yeah, maybe. But anyway, the thing is that I think we should maintain just only one, and I kind of think that def type is kind of misleading because in Haskell when you type the word type, like in here for instance, this is not a type. This is an alias, And I think it's kind of misleading to call the keyword of that being type. Because when you say the word type to me, I immediately think about ADTs.
Yeah, but take a look. Like an alias is a type. It is a type on the representation on REST, and it is a type to the user because the user can't tell the difference because it's effectively the same thing. They are used in the same way.
Okay, that's fair, I would say.
Hello.
Hello, Victor.
Hello.
Which stream should I watch here? There are two.
Mine, because Mageta is having dinner.
Okay.
Yeah, we are discussing grammar stuff because we are like improving our part. We should be we should be doing parsing, but we are discussing grammar for the
Well,
time
we
being.
can't do parsing if we don't know what to parse. Huh?
Yeah, no, I agree, but we were doing that, right? We
Where?
spent a lot of here. Here. All of this was done before talking about grammar at all.
No. Oh, okay, but okay, you mean without writing there, but we knew what would be the grammar. Otherwise, we couldn't write the parser.
Yeah, we kind of eyeball it, and I didn't like it back then. Like I really preferred this approach of talking about the grammar separately, and then we have a roadmap. Let's just follow the roadmap. While Mageta is having dinner, we can discuss about these other guys, right? These guys are all new this year.
Yeah, I think the only thing useful that we can discuss about is the type variable casing. How to
Well,
differentiate between like type variables and type aliases, and if we need to do that.
wait. How to differentiate between a type variable and a type alias? Because both of them start with a capital letter. Well, doesn't that couldn't we do that because of the context? Like in one context you have more
Nah,
information.
both are the same context. Both are types.
Both are no, but we don't have type alias in here yet.
Uh, yeah, but we will have, right? Then we need to think about the casing.
I think we should pick this problem to future us, man.
I think that's a bad
Because
idea because then you put whatever in the type variable. Oh yeah, we can change it, right? We can change it.
yeah, we can always change.
Yeah, it's okay.
Because as far as I can tell, you also told us before that type alias is not as easy to implement as we think.
Yeah, it is not.
Which sucks. Oh my god. Okay, so what about those we can we discuss? These ones.
Like I don't really have any opinion about it.
What do you mean, man?
Well, aside from that,
Okay, so I would define them. So let's discuss type variable. What is the
one way
grammar of type variable?
one way you could do it is to breed in the same way as types, but then you would do the following. How can I say? Like you try to parse the orders, right? And if you didn't match it, then it's a type variable, right? But they have the same casing. But
Yeah, but
that
I was
causes
thinking
the
about
thing
I was
that
talking about capitalizing this guy. Because I think it makes sense.
Okay,
Because
guys,
the
I'm
identifier is a string.
going to take a shower here.
Okay.
I'm here because I cannot use the computer. I'm testing all the RAM sticks individually.
But are they working individually?
So far, I'm on the third one. So
And it
so
is
far
working?
yes.
Who needs
Probably
dual
the
channel, man?
fourth one is.
Just go for it. Who needs dual channel?
Oh man, but the problem is that every time I reach like past 15 50 gigabytes of RAM, I get a blue screen of death or just crashes the kernel. So
Isn't that a Windows problem?
no, on Linux too. So if I do a huge build on NixOS and it goes after 50 gigabytes of RAM, I
Oh,
just
it's
get a kernel
oh my
panic.
god! It is when you're using it.
Yes, every time it reaches like 50 gigabytes,
Man, I didn't even test that with mine. Maybe it is
it
broke.
is literally the runtime weight of the system we work. So
Well, I think
Yeah,
you're
I
not
only
dragging
use, I don't know,
methods
maybe.
solution to that, right? Just don't use it more than 50.
yeah. Oh man, I just wish one of the sticks just I don't know gets an error so I can like just face the bureaucracy of replacing it, because if I
Yeah.
don't get an error, I'll probably just have to live with it. Oh man, this sucks. And it takes a lot of time, right, to test RAM. I didn't know this. Those memory tests take like 1 hour.
Yeah.
Okay, so I'm going to take a shower here and just
Yeah.
wait for the tests.
Okay.
Okay, see ya, dudes.
See ya.
Lemus, there is something wrong with our syntax. Identifier, not saying if it's lowercase or not.
Yeah, no, I just discovered that we're gonna have to. I'm trying to think how can I can write that now in our meta language. Because I was thinking
Lowercase identifier,
I was thinking about
uppercase
something
identifier.
like
Dude,
I
what
was
do
thinking
you...
about something like this.
Dude.
But well.
Oh, okay, you can use regex, yes. Yeah, just use regex. Yeah, not in that way, by the way.
Oh, you mean this way?
Yes.
Not a fan, but okay.
What do you mean, man? You saw Upper, right? Like, what the fuck?
No, I'm not saying the other way, but it was better.
Yeah, but that's incomplete, right?
Okay.
Yeah, that's
Now
man,
we
man,
do
that's still
capital
really wrong,
letter,
man.
and then
Dude,
identifier, and then we're done.
no, we're not done, Lemus. You cannot have the star there. Okay.
Oh, it needs to be a plus. Okay.
In the capital letter, you only have one letter, right?
Yeah, which is this, right?
Oh, okay, that's capital letter, not capital ident. Oh, identifier. I see. What is the use of? Oh, okay, that way. I see. Oh, now I got
Okay.
it.
Okay,
No,
now we
but
have a
then
type
that's
variable.
wrong. No, that's wrong. Because you need at
But
least
then
two.
that's wrong.
Yeah,
Wait, it is at least true. Where?
because it's at least the capital letter and the identifier that is at
Okay, I'm
least
back.
one.
Ah, crap.
Okay, I'm
Dude,
back. What's happening?
hello. Just do like upper lowercase letter, right? That is the A to Z. And then in one place you use that with the plus, in other place you use that with the star.
Okay, that makes sense.
Lem
Lower
is doing
letter.
like theoretical regex.
Oh, man.
Okay, so this is gonna be lower letter. Uh,
I always learn
Star.
rejects and I forget again.
Oh yeah, that happens all the time.
Yeah, then you don't have the like your identifier now it's a like lower letter plus, right?
Yeah. We were discussing how to do the type variable. That's why we're doing this.
Okay.
Okay, so and I can go back to identifier. Okay. So a type variable is just a capital letter with one or more lower letters. And an identifier cannot have capital letters.
Instead of making a restriction by the contents of the names, what about just doing a special character? Like, for
Yeah,
example,
that's a
But
possibility.
then you
I
need
didn't.
that every
Like this.
Wow.
Instead of handling Visa generics, it could be like generics like Haskell.
No,
Like
but
A.
the Haskell one is just A. Then we're gonna have
Yes,
a bad
that's the
a
thing.
bad
But
time.
like for a variable, you can put this.
Oh, I see.
I
think
kind of
it's
prefer the
better.
opposite though. These would be a type variable and normal stuff would be just identifier.
Yeah, that's exactly what I say. I'm not saying
No, I
this
understood the
for-
opposite. I understood
No,
the
man.
opposite.
I think both are fine.
Yeah, because dude, I think it's such a shady restriction to not allow like uppercase.
Identifiers as capital letters.
Yes, like better to make it explicit or something like in Lisp that you can do.
I like your idea. Let's go back and
Yeah, or
let's.
something like this. Like, do you remember the people do this or the earmuffs for like a global? We can inherit
I
that.
think there is a point, Magenta, actually. Well,
Yeah.
kind of. Yeah, I think
No, I
there is a
prefer.
point. So with the variable thing, I think it should be more like open, because then you can define things on your own, like plus and stuff. And since they are all prefixed, they all make sense. Not like if you declare a crazy thing, it will be like infixed, right? That would be terrible. But for types, I don't think it makes sense for you to allow like too much freedom. Because dude,
Yeah, I agree. I agree.
right?
But that's what I'm saying. Like, for example, this or this, like, it wouldn't make sense because you basically allow one letter, like, I don't know,
Wait, that's
T,
not for
but
types, right?
no, this could be for types. I don't know.
Dude, why? Why would
I
someone
don't
do
know,
that?
man. Just to wrap. I don't know. Just to identify this is a
Oh man, I
value.
feel so bad.
That's all.
Commander was here and then he said, "How's it going?" But I didn't read it. And okay, I guess I'll go to sleep.
Oh man.
So
Or
sad.
this. Or what about this?
Oh, the at.
Oh, we're already doing at for splicing. I think when we do macros.
No, but
No,
we don't have
nothing.
macros.
No,
We're
no, no,
talking
no,
about.
no, 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 no.
What
No,
are you
wait.
talking
No,
about?
I'm talking about this. Like you have. Oh man. Like this. Like this is like in Lisp just this. This, for example.
Wait, what the hell? What is on the left, man?
No, this is splicing. We are unpacking the stuff from here to the outer list.
Oh, do you have? Don't you
Wow.
have something?
Were
So
we
like
planning to
see?
use that?
Yeah, so that's the question. Like,
Isn't the dot something like that?
isn't what?
The
Sorry.
dot?
No, there's no dot. There's comma. There's a dot, but that is for
Then I'm confusing the
a
language, I
dotted
guess.
list. Yeah, in Scheme you have this. In Lisp you also have this. This is a dotted list. This is just like a cons here of these two things.
Okay.
Well, we also right now because we dropped the variadic part, we could do type variables with this before.
Yeah.
That's a possibility. To
Dude,
get
just stick with the normal one. It's either like uppercase or to have like the thing as in F sharp or kind of like, why going crazy with that, man?
because we can. Why?
Just-
It's
Even if we
exactly.
can, that's usually not a reason to do something. Like you can like do a bunch of stuff right now. You're not
No,
What do
but
you
this
do?
is just no, but this is a very just a static decision because
Okay,
you
then you
prefer
can say,
this
oh, because I
or
think
prefer
it's pretty,
this.
right?
Yeah, but the reason why it's because we can and we can make what we think it is best.
No, if you are saying that, then you are saying, oh, because it's pretty or something. That's not the same as because we can.
No, because we can make the decision
Let's
of
not
making it
discuss
prettier.
about that now, man. Let's not discuss that.
Well, choose one and let's do the parsing, right?
Okay, so it's gonna be the % just because lols. Okay,
But I
so
don't like the ampersand.
okay, so let's do the F sharp way, which is gonna be like this.
That is also not cool, man. What about
Well,
this?
it's easy to change it later.
That's a kind thing. This.
Yeah.
Oh, this is perfect. I love this. Oh, that's not good, right? You can barely see.
we can change it later. Let's stick with the F sharp for now. We can change it later. Anyway, so So what we were discussing before? Oh yeah, before you left, we were discussing about doing def alias and def type, and then my Nathan asked me how SML does it, and I found it, which is that SML, as far as I can tell, uses type for type alias, is
Yes, and
data type
yes,
for
data
ADTs,
type and type. Yes.
which means that we probably, I don't know. I prefer making the alias like this, and then doing the ADTs as def algebraic.
Lemos, just
I like that.
like a side question. Are we doing our how can I say, our language as a library there,
Our language as a library. What do you mean?
as an application?
I don't understand what you mean by that.
Yeah.
Because in Haskell, I would suppose you can either do a binary or lib, right? And they are
Oh, I mean
I
now.
see,
Okay.
see.
so we are doing as a library, right?
I don't remember the difference anymore.
Uh,
Too much
Oh,
time.
What?
if you're talking, wait, say the point again, Nathan.
Oh,
If
you
we-
mean using as a language to make an application, or in
Okay.
another
or
one
to
to have a library?
We
execute,
have
to
either
allow
a binary
execution,
or a library, right? If we do our language as the binary, then we can't reuse stuff, right?
yeah.
Mm-hmm.
So that's my question. Are we using as a library? Like, it's probably something on your project, right? I guess that if you go on configurations, but we can see that later. It's just that then we can like reuse stuff. So CLI could be a binary that uses that library, right?
Mhm.
Mm-hmm. Mm-hmm.
And then I can use the library to write the AST directly, right?
Oh yeah, yeah, that's true. That's true. That's totally
Wait, what do you
possible.
mean by what do you mean by write the ST directly? I
Because
don't know
then
if
the
I got
tooling
that.
can do that, right?
Yeah.
Because then the tooling can do that. I don't know if I got that, but okay.
Oh, he's talking about like an editor, like doing the thing or something, right? Is that it, Nathan?
Yeah, any tooling.
Any tooling?
Yeah,
What
like
do you mean
you
by any?
see how we have like F# compiler services.
Yes.
That's because like they are disponibilizing as a library, right?
Oh, I see. I got the point. Like for example, for the LSP, we could just embed the stuff in the compiler, right? So we get the parser, for example.
Oh, treating as a library is not like you don't have a main function. You have access to all
Yeah.
the
Yeah.
crap. Oh,
No, you can still have that, I guess, but
I don't think I have a main function in libraries, man.
yeah, that's usually very, very uncommon, I would say.
yeah,
It's
I,
usual
I
to have a main function in a test file
yeah.
of the
Here's the
library.
point:
Because it's a
we're not
binary.
splitting, right? Oh man, okay. I don't know how Stack works, but we're not splitting stuff in like projects, right, and binding them together.
Aren't we? Like,
I don't
No,
think
no,
so.
this is a
Like,
single project. This is a single project at the moment.
yeah, like in .NET, you could do the CS or
Yeah, but
FS
this is not
project,
hard to
right?
this is not
For
hard to
each.
discover because we just go to a open source Haskell library and go to get their
So
GitHub
we
and see how
could,
they are
yeah,
doing.
so we
they
could
have like
have our,
lib and that, right?
so we could
Yeah, they
have
do.
our Silverware compiler
Yeah,
services.
yeah, exactly.
That'd be awesome.
Microservice in
Yeah,
Silverware.
like your LSP server could literally be a binary that imports the lib of the language and does stuff.
Yeah, as far as I can tell, yeah. Anyway, so
Oh, by the
let's
way,
make the decision.
my idea there, I was thinking about the runtime thing,
Mm-hmm.
and that gave me an idea, but we would probably need some adaptation. We are now just interpreting, right?
Yeah, right now,
When
yes.
we compile, we can basically just do any language compile to this if we don't have too much. Well, we just transcribe the code to a sort of a silverware-ish thing, and then we can just make any syntax really that matches with the features, of course. Do you get what I mean? So, for example,
No.
you can have language like Silverware Plus, open, Silverware Plus, and I don't know, eCaml. You can have those two. And they're like made in totally different ways. Like they have different syntax, but they have like feature parity. in a lot of senses. And
Oh,
then
you
can
mean
just like
having an intermediate representation for both?
yeah, exactly. So we can
Oh
just
my
compile
god.
them. Like
Yeah, Magetta just expanded this to like 1.5 years more.
no, I just giving the idea. Like you see what I mean? Like this could be anyway.
Yeah, we would have to create it like, and that is very very like
By
deep
the way,
stuff because
we need one anyway, Lemos.
really, why?
Well, because it's easier to compile because we need simpler
Oh,
stuff, right? To compile.
oh yeah, that's true. Yeah,
Oh, we're gonna have to create intermediate representation. Ah.
well, that's not a bad thing, man. Just do it.
Because I think that in the process of making the thing, I think the where we're gonna regret the most doing ad hoc stuff is gonna be the intermediate representation.
I
That's
don't know.
I don't know,
I
man.
have a feeling about that the intermediate representation requires more like effort because if you screw that up, it's gonna be really like later you're gonna have to change the compiler with assembly stuff and well anyway.
Well, I only know
Oh,
that it's
okay,
hard
yes, it's
because you have to
painful.
translate complex features in simpler features, right? So that part is hard.
Yeah,
Okay, but that's a problem for future us. Right now,
yes.
let's discuss which type alias syntax we're gonna use. This one or the other one. I don't like the word types to define aliases, so I'm voting for the second.
Why not both again?
Because
My vote is neutral, by the way. I vote no.
I vote no.
I vote no.
Oh, so that is not neutral. That is a value to be yet discovered. That's no.
Or a value that is accepted everywhere.
That's no. A value yet to be discovered.
Anyway, so what do you think, Magetta?
I don't know, man. Keep them both. Who cares?
Okay, for now I think that's fine. So this is gonna be the aliases. So
By the way, that's
aliases.
just a NOR on the string parser, right?
Yes.
That's just a NOR.
Hey,
Or
like you place
Oh, a
the first
NOR. Yeah, it
other
is. It
things.
is just a OR in the string parser. This is ADTs in records.
what is the record,
Actually,
by the
let's
way,
do with
Magenta?
the org. What is? Oh yes, we didn't do a record. How should the record be?
Yeah.
Let me think. Oh, enclosure, they're like this. Oopsie. Well, you def. This is for
Dude, it could say
thing.
it could be literally the same syntax.
Yeah, it could be, but I prefer def records. That's true. And then we can
Yeah,
do
because
like
you
I don't
need to
know.
distinguish some way though.
Yeah,
Yeah.
in closure, I think they just use commas to separate. Like, but I think it would be better just doing what we are doing there, which is like this. Like, it can be the same syntax, you know?
Yeah, I think it makes sense. Oh, but you are missing the name. So there's a name.
Oh, yes, that's true. Yeah, we can do this, man.
And then this name can also has a parametric crap, which is this. Uh, yeah, yeah,
It can be
yeah. So
literally
the
the same thing.
records will be the same as the def of the ADTs, but just changing the keyword from
Lance,
def of Jailbreak to def
by
of.
the way, that's a nice thing, right? Because you see the syntax there that you have for ADTs and for records.
Yeah,
The AST representation of like ADTs and records, it's exactly the same also.
Mm-hmm.
yeah. That's
Like
a good.
it's a list of like label and type, right?
Yeah, yeah, and we already have that, right? We already did it once for the lats, so it's kind of like
Yeah,
copy pasting
it
code
only
again.
changes. Oh, hey, have we decided if we have like more than one type per case in algebraic?
Oh, good. What about
Wait, what
we
was the
do?
question?
Can you do a integer
A integer integer.
in algebraic?
Oh,
Oh,
wait.
in algebraic, a integer integer. You mean this?
Yeah,
So your question is about having a
it's like a
product type.
yeah.
No, no, no.
I
That's not a. Well, how can I say? It's not the product type per se. It's just like. Shit, man.
What do you mean, man?
What?
Yeah,
I don't
it's
understand as
not a
well.
product type. You are just getting two arguments.
Oh, okay. It's either. It's like an either. Something like
No,
this.
no, no, no. A takes
Hmm.
two integers. And that's not exactly a product type. A product type would be, oh, A takes one type, and that type is a
We are
product
talking
type.
like a sum that takes
That's
a.
not how it works in Haskell.
So a sum takes a t, right? So you're saying as if the sum took 2.
Yeah.
Is that it?
What happens
Yeah.
in this case is that we can do the
Yeah, that
partial
would be.
application, right?
Yeah, so like it could be
Yeah,
this,
in
right?
Haskell, a product type can be partially applied. So.
Okay,
Well.
this I get it. It could be like this, right?
Yeah, but then x is a function, right? In that case. Yeah, and then you pass 2 to x, which is gonna be sum
Yeah.
1 2, right? Yeah, so basically copy pasting the product type in Haskell. Okay, that's fine for me. So. Oh, but then that's different than. No, the records and the ADTs is still the same, right, Nathan?
Hmm?
Because you can also have a record like that with that, right?
No, you can't.
You can't.
Well, I guess you could, but wait.
How about we would make a
No,
record that.
you couldn't. You couldn't. The record can only receive one type. If you need something more, then it's a product type, like a tuple, right?
No, but can you have a field of a record in which one of the fields is acting as we just described?
No, we can't. We can
We
only have
can't.
one type, and if you want multiple things on that type, then the type must be a product type, like either another record or a tuple. That's why
So
I'm
you
not.
cannot.
That's why
So you
I'm not
cannot do
saying.
like things like this, right?
No, you can't.
I never tested this in Haskell, so I don't know.
It's because Haskell doesn't. Man, Haskell is broken. Just accept.
No, Haskell has a broken def record because it is very, very. How can I say?
It's just totally broken. We get
No, no,
it.
no. We already had this discussion. Haskell is the only one that is using product types all the way through, even in records. Which is bad because we want something more to records, not just product types properties. But anyway, that was just a question. But I think this means that the records and the DTs down there are different, right? They are not.
Yeah,
They don't
yeah.
have the same
Yeah,
representation.
now you get a list of pairs that the left pair it's a label and the right pair it's a list of types when it's an ADT. But when it's a record,
Yeah,
it's only one.
yeah, yeah. That makes sense. Okay, last one. Final global values.
Global value.
Which is when you have a declaration that is in the global scope.
By the way, isn't the X outside?
Is the X outside? Outside of what?
Outside of the parentheses?
No. The X
No.
has the X should be inside.
Wait.
Because this is
Define.
binding a name with a type.
Oh, okay. I was thinking about the function. Okay, that's just a value, right? You don't
Yeah.
need the type then.
No, but then we need type inference, which we don't have.
No. You don't need the type then.
You wouldn't need. No, we do have. On that case, we do.
No,
Like we could
don't.
define
No,
X.
we don't need a type. We can
No,
have.
we don't. But we can. That's the
Yeah.
point.
Then,
No, we need a type because otherwise we need to inference the type of this.
Man,
No, we already do that. Like we're
that's
just
an
gonna.
integer. How don't you know what an integer is?
Yes. You have a literal and you have X. What
Yeah,
is
the
the type of X in the
case
context?
in
It's an
which I
integer.
can think that we can have problems is if we had both these representation, these two representations for integers, right?
Yeah, so the
Which
only thing
are
that
different.
happens is that our type is a type annotation, right? So we will
Yeah.
just check against it.
Yeah. But maybe, yeah, we are right. We
So
can
yeah,
we
it's
can do.
optional, right?
Yeah, we can need to make a maybe in the AST for this.
That's fine.
Yeah. Anyway, we need to decide between these two. So define and def value.
Should we do define or just use the lets?
That's a good question.
Oh.
Because then it's all generic, right? You bind functions, you do everything.
Would we have some problem parsing? Like,
Good
Would we
question.
have problem in parsing? I don't think so.
can you show the syntax for the other lets?
Oh no, wait. We don't have a way to assign to a label on the let, right?
Huh?
No, we do.
No, we
We are
don't.
doing that. No, we are doing that.
Wait, can you show the syntax
Show the
for the
syntax.
let thing?
Okay, I can
It's
show.
in
I can
here.
show the syntax. Go to type.hs.
It's in here.
By the way, I'm watching
Oh.
Lemos.
Oh, he's here. He's here. Okay, go on. Go on, Magetta.
Yeah, but like for example, let we are not assigning this. This could be a function, correct?
Could this be a function?
Well, in this case, no, right? You're assigning this kind of stuff here. But if you were
Yeah.
just like,
Oh, but we would have to change the implementation because
Yeah,
this label is
yeah, this
binded to
is-
this expression only in the context of this body.
No,
Yeah,
but
but
that's
it
right.
could
That's a
be-
let thing. It's an expression
Yes.
and not a declaration, right?
yeah, but it could be a function here. You see? So that's what I'm saying.
Yes.
But then we have a new, like we have another body that is. I don't know
Oh, we
what
would
it
have to have a lambda here. That's what you're saying.
is. Yes.
Oh, that's possible. That's possible. That's possible.
Unless you
Which
want
actually-
more syntax sugar, right?
Which is very good because in Lisp to do that you would have to do like flat or crap.
Yeah.
Hey,
But I think we can do just the defun, right? In Lisp, defun. The
Go on,
function.
Nathan.
I think it's better.
we can use both as let Magetta because we can distinguish even by the let in using brackets and the other using parentheses.
What is the
Oh,
other one?
see,
Like
see,
both
see.
let in and let declaration, both could be using let, right? They have
Mhm.
different.
Yeah, but
syntax.
I'm thinking. Yeah, but I'm thinking. Wait.
Like
It is-
this, right, Nathan? Like x, lambda.
Yeah, but then how do you have the type there? I was talking about the one that you wrote on the other place.
Okay, it could
Oh.
be this in this case.
No, but then you do like that.
Yeah, but
No,
anyway,
wait,
we can
that was a
distinguish
different
both.
thing.
That's my point. We can distinguish
No.
both.
We can distinguish. I agree. But I don't know if I like this reusing let for this. Kinda.
Well, we could use the define, right?
Yeah, that's why I suggested to the define. And this approach here is also like what Magetta said. We can just use a let, and then the program that you want to run, like your main function, could be this body, right? But then that would suck because let's imagine that you want, like, you made an entire program, like an entire main function, and you want to add a
Yeah.
variable before. You're gonna have to add
No,
brackets
no.
before and
Wait,
after.
I'm not getting it. Can you?
Yeah, I can repeat. So let's suppose that you want to have a variable that has the value 1 for the entire main function.
For
So
the
what-
entire
how-
main function. What do you mean
Yeah.
by main function?
Yeah, let's suppose that you have a def fun here. So def fun main and then whatever. And then, I want to execute the def main function, but I want to have a global variable in order its execution. Then you just call main and you, yeah, that's it.
I'm not getting it.
So what I think it sucks is that if you want to add a global value for the function later, like after you made the entire program, you want to add something, you're gonna have to add a bracket before and after. I don't like that. That's why I'm saying that we shouldn't use the let
Dude,
for the
wait,
def
can you
values.
show me what you can't do? Like, I'm not getting the problem. I'm not
No, it's
even
just a personal
understand-
preference.
No, I'm not even understand what the code is.
Okay, so this let block here, you are defining a variable called ABC with the value 1, and this is in the scope of this.
No. It's not.
No.
What?
I'm explaining it wrong. So just imagine that your main function is here.
Okay.
Okay.
Whatever. ABC, whatever. I was just thinking simple substitution. That's why I did it that other way. So the thing is that during this manner, if you want to, I have my main function, which is all of this crap.
The body, right?
Yeah, I want to add a variable. I need to add a bracket after the this and before, and add the ABC. I need to wrap the function with the let block. You see, And in the other way, you can just do like this. Oh, I have that. Oh, I want to add a new variable. Okay, so you just define ABC x integer
That's strange. Do you know
1.
why? Because first, you don't
Done.
need to wrap anything. You have a list of bindings. You just put brackets there. It's not a wrap on everything, right?
No, it is because you need to wrap the let, right? You need to do what we
No.
did last
Once you
session.
already have a
Can,
let,
can you look here?
Yeah, I can.
yeah.
So I made two things. Like this would be the let in, right? So you have
Yes.
this being defined in here.
Yes.
And this would be a let for a function. So you have let ABC that takes a parameter. So that's the distinction.
Wait. Yeah, but that's that. We would have to change the.
Yeah, but here's the thing. In this case, you have to differentiate these two lets because this is not allowing you to define something that is, well, we can think of that.
Wait.
Like this cannot be a literal, right? This needs to be a type definition because now this is abstracting a function and so on.
Yeah.
So I don't know. I kind of prefer to do it different. I think this way is kind of.
Yeah.
What is the comparison that we are doing again?
No, he's not comparing. He's just showing us the difference between our current let and what it would be the other, like the cousin of the let, which is this second one that we don't have.
This is literally the fun.
Defun, yeah.
Okay.
But we can do the F sharp way and just do let for both, right? For
That's
both.
why I wanted to add names, man, because in this case, like, it would be like let fun.
Oh. Why don't you call the other let in?
Oh yeah, that's true.
Anyway, I prefer def fun and lets being normal lets. That's my personal preference. I'm going back to the
to call
grammar.
them lets.
I don't care about the names.
Let's go back. So global values
Yeah,
should be define or define def value.
I have a preference of def value because then we would be consistent with the other names. Like def algebraic, def type, def alias, def record. And you want to have a value in your global context. You just do that. That's what I thought. What do you think, Mageta? Because Nathan doesn't care.
I kind of okay. I get it. Yeah, to keep consistent with the depths here. Let's keep it this way. Depth value. Yeah, that's fine to me.
Okay, so now we can go to the grammar and add those. Okay, so.
By the way,
Actually,
regarding
go.
what is on the top level, we have expressions there. I think that
Yes.
influences the most regarding, I mean, do we want? I think that only influences regarding we executing side effects, right? In the sense that, suppose in OCaml, right? In OCaml, you can't just call a function like there on the top level. You need to do a declaration, right? And then you do the unit stuff that Lemus saw. Like, so,
the Lemus cringed on.
Yeah, totally cringe on.
So which one do we want, right? so yeah, if you have expression there on declarations, then you can do just the print, right, Mageta?
And we also need to add functions here.
Yeah, like this, right?
Function? What do you mean?
Yeah, because we can define a function, right? Like
the functions and global values are not being the same thing for you guys?
Yeah.
Of course not, man.
What do you mean by of course not?
No, wait. This syntax is wrong for a value, for a literal. Right? We shouldn't be... Okay, I get it. I get what you're thinking here. We should be just x, which has a type integer that takes this, right? And then we could swap here by a function, and then we can annotate here.
No. Let me make myself clear. When I suggested to have global values, it is exactly the forbidden and cursed meaning that global values have in C. Right? No, aside from the mutability. So what a global value in, like, I don't know, back in the day means? It means that you have a value that is available for all functions because it is written in
That
a
only
global
makes
context.
sense in procedural languages, where you only have normally like procedures in the top level.
No,
Oh,
no,
but
that's not correct.
no,
You can
no, no, no.
also have
Like,
functional languages that take advantage of global values. I did it all the I do
No,
it all the
no.
time.
What I mean is calling global value makes sense when you have a procedural language because normally you only have
no,
procedures.
no, no. But no, man. I think the point he's making is
No,
like
man,
something
you're
like,
not
for
getting that.
example, like picture an Okamo module that you basically just do a let x equals 1.
Sure.
And then you have another thing that just do, I don't know, a function that is ABC that picks an A and B,
And do x plus a plus b.
Okay.
x plus y plus A plus B.
And then
So
you have
that's an
another
usage.
function down here
So
called
this
def.
would be kind of a letting in this function, right? Do you agree?
Yes, yes. But in the
Okay.
functional languages, because we have the sense of like this it is the same crap as in C,
Yeah,
but it's different
this
syntax.
in on the top level stuff is a bit of a lie. It's more for you to think about it.
Mhm.
Yeah, but it is Magetta got the point. So if you have different functions that do different things, and then you want
Okay.
you want to be able to do stuff like this, right? Because and what is the use case of that? What is the use case of that? Let me do an example. So when I was making this, I thought, okay, I'm gonna have an integer 1, 2, 3, and then oh, we are gonna do a def I don't know, oh man, I don't know, whatever, and then it's gonna receive stuff. I'm doing whatever syntax here, and then you're gonna do I want to use that x up there, and then you're gonna do computations. In the middle of computations, you're gonna have x, and you're not receiving as a parameter, as you can see here.
Okay.
And then you can have another function down, like totally not related to the first one, that also is using x in a different manner. It's receiving other stuff like this, and then it's exactly what we did in lattice, right? In lattice, we had a bunch of constants that we wanted to keep using all the time, but we didn't want to pass those constants to all the functions all the time.
Yeah, like I got like any normal sane language. I'm not getting the point. Like
that take any normal syntax.
Yes.
yeah, so I don't get why you are
Detail. Yeah,
doing
detail. Erlang
so.
doesn't allow that.
Yeah, not a sane language.
Uh,
So that's what I meant with global values. Because if you want to do a function,
Oh yeah,
you
but
just
that's
do
the
that
whole
function.
point of declaration. Like
but how did we get into this discussion if everybody
Because
agrees?
because we are we are discussing what is a declaration. Because a file is composed of multiple declarations.
okay.
Then
Okay,
we decided, okay, you can
so I
declare
will
an
hammer
expression.
syntax here. So def value for a literal. So I still think this is weird. Let's make it consistent. So this should be like this. Like this.
Yeah, I don't understand what the problem was before, but for me
Because
that's
this is the
fine.
name. Like this is the name of the thing, right? And you're
Yeah.
assigning this. How function could be declared like that? Def
No, no,
value is
no.
kind of
But
weird
if you
for a
want to,
function.
no, if you want to define a function, you're not gonna use def value. You're gonna use def fun.
Oh, okay, was that the problem, right? So yeah, syntax-wise, you can call whatever, but they will be the same in the end.
Okay, I'm gonna even remove the word global. Anyway, so then the def fun can be whatever you guys prefer. But I was just talking about having like numbers and fractions and strings that we don't want to keep passing over and over again to everybody.
Also known as let.
But then
Yes.
that's what we were discussing before, right?
Yeah. Okay.
About
That's
using or
how you
not
got there. Okay. Get it.
using or not using the let
Okay, not using
as
the
a
name
use case for
let. Let's
this.
be more generic. It's a top-level declaration.
Yes, it is a top level declaration in which in F sharp you use the let to do that. In Haskell you just do whatever. You can just put like name equals. Uh, and now we're discussing for our stuff. So Oh, and by the way, Magetta, this is why I did it with parentheses wrapping both,
Yeah, it
because the
should be.
functions.
Yeah, but here's the thing. This is the name of the parameter, right? This is the name of the value.
Oh, I see. Okay, okay. Now I agree. Yeah, but there's actually a. No, I saw a problem now. Now that we have both like in contracts with each other, what if I do this here?
Well, that's wrong, right?
No, that's valid. Then
That's
your
Exactly.
valid.
value it's just a lambda. That's normal.
Yeah, but it's a lambda that just takes what?
In this
One
case,
No,
it
no.
takes
value?
Then
I
that's
don't
a
have a
valid
return.
type.
this.
No,
Yes,
that's a
yeah, that's
valid
my
arrow
point.
type.
It should be unit, right?
Oh yeah, we in unit our unit is written.
Yeah, but shouldn't unit
Anyway.
be inside parentheses?
It should. Yeah.
Oh
It
yes,
should.
that's true.
Anyway, so now we have a problem because this is a def fun, right? But
Yes, this is just an
But you don't
alias,
have a
right?
way to like disallow that, man.
Yeah, that's
okay, now we have
even.
a good proposal to
Well,
just nuke
unless you
this.
disallow anonymous functions, right?
No. Let's not do that.
I don't know.
Okay. Okay, so I'm convinced. So we're just gonna have expressions, type declaration, and functions.
That's wrong, man. If you say function, then how will I declare the x equal 1? Like, the name is very misleading if you can still do that.
Yeah, I agree. Just keep it that way, man. Okay.
Just call it like, I don't know, man. Let, global value, but it's one thing. Like, they are the same, right?
Okay, so we're not gonna care, at least at first glance, that you can put an arrow.
Yeah, what's the problem?
No, that's not a problem. It works by default, Lamps.
Yeah.
No, it will work, but it would be kind of like you were calling this a value, but this is a function.
No, it
Dude,
is a value.
that-
A function is a
Yes,
value,
but
dude.
dude, yes, that's the problem. Like that's why in F sharp and Okamo it's the same word. Like because there's no difference.
Yeah, but you can still do like let x equals to lambda, right?
Yeah.
So I don't see a problem there.
Yeah.
Would
Yeah,
be
yeah,
just
okay.
a weird thing for the user to do, right?
Yeah, it would be really weird.
Ooh, wait, I forgot how is the syntax of this.
It's like this: you
Actually,
receive an
Okay.
I have a
integer.
use case for doing that. Now.
Wait, this is wrong.
Like this.
Wait.
We need a name. We would need a name that does like, but the name is the let. The people already chose it, so. Ah. Anyway, so let's keep with the def values.
Let's just do let, man. Like def let.
Like if you, no, just don't. If you don't want the name let, you could do like def or define, man.
Def let, perfect.
That's bullshit.
Def let, man. I don't know what you're talking about.
Well, you can choose that. I will not write the syntax anyway.
Anyway, we can keep going here, but it's already 2 hours and something. So I think we should end this. We did kind parsing and we discussed a lot of grammar. It was already okay for me. Because this is important for our future stuff.
I will try to start the LSP. I don't know how far I will go, but
If you convince Victor to do in Go, that would be amazing.
um,
Anyway, Nathan, can you finish the recording?
Yes.
I have to install